Namaskar everyone. I, Niti Dugaya, on behalf of Department of Electrical and Electronics Engineering, Sagar Institute of welcomes you all to this webinar, which we have named SAGE Talk on career in modern robotics with special focus on probabilistic robotics. We welcome our guest, Mr. Anirban Ghatak. We are fortunate to have you with us. So I welcome Mr. The webinar. I would like all the participants to know something about the SAGE group. So I would request SAGE video for us. Amit sir, please play the video.
Yes, ma'am.
So thank you for watching the video. Now I would like to, on behalf of EX Department SIRT. Can you please share the slide? introduce Mr. Anirban. He has over software consulting, data and IT link in the UK, India. 3 years, he has been a successful entrepreneur and is the founder of MieRobot. MieRobot. MieRobot is a B2B brand that offers consulting Azure, big data, data lake, AWS, machine learning, open source blockchain, and ROS robotics. Anirban is also the author of two robotic courses in SP8266 and robot operating system. Anirban is passionate about STEM education in India with project-based support, small business initiatives, collaboration and manufacturing in India. We have already conducted one stage talk, that is webinar on data science previously in June with us. And over to you. Thank you.
Thank you, Nidhi. I'll just go to my main slide again.
I'm glad that over 500 participants are there in our webinar today through our YouTube streaming. And there would be some instructions that the section will be in two parts. There will be a wait in between, and the chat will be YouTube live session will be continuing. And the question and answer session could be taken in the YouTube chat box. We ask speaker from your behalf. So feel free to drop your question in chat box. Yes, you can continue, sir.
Thank you, Sage Talk. Thank you, Professor Nidhi. Thank you, dear students, participants who are joining this live from YouTube. I welcome all of you. So before we get started, feedback from the previous data science webinar, because this is a 360-degree feedback. Last time मैंने webinar किया था, आप लोगों ने feedback दिया था. So this is my turn to play back. What was my feedback on Sage Tech? I think the experience was amazing, as I can say, because one thing which I really liked was the faculty members who attended the previous data science webinar. They were so open in giving feedback. And this is, I'll be honest with all of you, this is something which I don't see as a trend. I see students giving feedback and maybe one or two faculty members giving a feedback from such a open webinar, but it was really very encouraging to see almost all the faculty members of Sage Talk directly and indirectly participating in the feedback, and all of them had 5-star ratings on the talk. So that is really encouraging, and I think where the gurus are itself so much willing to learn, it will automatically play back into the education system and the ecosystem. So well done, and that was my feedback from the previous webinar. All right, let's get started. So goodies for the webinar, because since this is a second webinar, and when I present and I repeat my webinars to a particular institute, I increase the level. The benefits you get out of the webinar increases, because that is a motivation for people to constantly upgrade themselves and better the quality, not only from my side but also from the participant side. So today, if you're registered for the webinar, you would get a Ubuntu version of ROS Melodic installed. The installation is quite complicated. If you have tried ROS, you would have seen that it's not so easy. So I'll give you a virtual box with Ubuntu over Ubuntu, which you can install in Oracle VM. And whatever you have learned from this webinar, at least the starting step you can take and put it in your personal laptop or in your college lab and get started. So I'll be actually giving you the platform, all right? And it's an open source platform. I've configured everything for you, and all you need to do is import, and you can get going with the environment in 10 minutes. So that's the brownie point that is coming because this is the second webinar I'm doing for Sage Talk. Students and faculty members who have done my webinars, they know that I work on a theme when I work on a webinar. Last time when I was doing data science for the electrical engineers, gave the example as a theme of Henry Ford from automotive engineering. Today, our theme would be quotations from our ex-president, our lovable Kalam sir, and he's going to be his quotes and inspiring lines would motivate us to learn ROS and robotics, and I'll be using his quotation to motivate all of you. All right. So the first theme is strength, respect, strength, and this was a quotation of which Kalam sir said, in which he said that we need to up ourselves as a nation, as individual, as company, as engineering college, as engineers, doctors, because if we don't up our game, the world will not respect us. So we need to develop that strength internally. Our capabilities has to be developed internally so that the ecosystem starts respecting us more, right? So if we want that, a top paying company comes for placement in our campus, we have to improve our game plan. We have to take our level to the expectation that company is expecting from us. So it's a self introspecting and self improvement process. All right. So let's move to the next slide. So the first problem statement is that what actually is a robot in 2020, all right? Because I need to set up certain foundations before I go to, probabilistic robotics and ROS. So I'll be taking you into a journey of robotics, but it's very important that we shatter some myths because robotics is a very spicy topic, right? Isn't it? It's very interesting, it's very spicy, and there are a lot of movies which are made on it, and it gives us an illusion about the technology where it is, and which may or may not be correct. So the first thing I need to address in this forum is what actually is a robot in 2020. Is it a robot like you see in the Wall-E where it has developed human emotion as falling in love? Is it possible? All right, or how far we are from actually to that positioning where a machine can fall in love? Okay, is that actually the fact? Now films and robot, they go hand in hand. Probably when I was a student, this was my kind of movie with Terminator coming in and there was an android, and probably now you guys are students and you have this kind of robot which was the TARS robot which you've seen in the Hollywood movies. So are these the robots which actually exist? Or when we talk about robotics, are we trying to create such kind of robots? If no, then how far we from reality? And if yes, can I see some example of such robots in real life far from movies? So, even in this last, 30 years, robots has been fascinating in the film industry, both for me when I was a college student and for you when you are a college student. Robotics is there in our imagination, be it in science fiction, be it in movies, right? So this is the reality of TARS, my friend. So this is the TARS robot which you saw in the movie, and actually you see that it was actually a puppet matlab khilona, all right? And there was a man who is in that suit who was actually pushing this robot to do those movements actually. Correct. And this color is given so that it does not come and it is easier to edit. And that is how the robot was actually moving. So obviously a robot like TARS is not available. We haven't reached that stage yet. So you actually saw a puppet moving with in your screen, and I think it is a hallmark of computer editing. Yeah, it's a hallmark of computer editing or VFX, which we say in technical word, rather than robotics, right? It is not a hallmark of robotics because TARS did not exist, or robots like TARS, we are quite away from that, all right? So that's the thing. Then what are robots, right? I have confused you more because now, some of you thought that, that is what I would be doing and I would create robot like TARS. But if that's not the robot in 2020, where are the robots? Where are the robots? Where do I find them? And how do they look? What is the reality, right? So you have become more confused. And my job is to take down that confusion. Now, couple of options. Option one, is this robotics? Okay, option one. And all of you probably know Arduino. And this kind of robots are there in the campus, right? All campuses in India have this kind of robot where you have a microcontroller, some power source, some electronic circuits, and they actually move some kind of servo. or a DC motor, and they interface with sensors and analog and digital pin, correct? So are these robots? Food for thought, right? Or option two, Raspberry Pi. People who have mastered Arduino, they move into Raspberry Pi, which is nothing but a single board computer, runs on some flavor of Unix, and again, it has a GPIO ports, and you can also interface with a microcontroller like Arduino, and you can make fascinating projects on Internet of Things. Maybe you call it robotics, so on and so forth. So is this the right option? Option two? Chat, put your comment in the chat. Do you think option one and option two? I give you 5 seconds. One, two, three, four, five. All right. So the thing I ask my students, when I teach them robotics, that, if you see a robot which is there in a school and a class 8 student is able to make it, what is the difference between your robot, which a class 8 student is making, and a BTech third year? And if you are making the same robot as a class 8 student, then there is some gap, right? Now, if you go to any school, in Bhopal, go to any good school in Bhopal, which is there for 10, 15 years, and go to their science exhibition. I actually given this as an assignment to my students, and my students, some of them have did and said that, sir, you're spot on. You would see that the robotic projects between a school and an engineering college, unfortunately, there is not much difference. In fact, in school, you also see, things like Lego Mindstorms and all coming in. Now, and which is probably good for a school level project. But we can't say the same thing. There should be some difference between class 8 and a third year BTech electrical, electronics, computer science, robotics project. Unfortunately, I don't see the difference, and that's where probably the problem is. I also see projects which I was also doing when I was a kid, and there is a joke in my family that probably the national science project is one of the national science project is a water meter. So what happens in a water meter kind of a project? And I bet everybody has seen this project. All right, you have a tank which fills up water, and when that water is about to fall, there is an alarm which comes in. Haven't you seen this project? You know, I had seen this project from 1990, to be honest to you. I still see it. My question to you is, how many of you have an water alarming system at your home? Do you have a water alarming system at your home? Probably no. If this use case was so important, all of us would have had a water alarming system at our home as we have mobile. I did some research that how do they actually alert when water is going to fall in a municipality, or thing where they have big tanks. They actually have a role for a pump person whose daily job is to switch on and off the pump. So it is actually not needed. In our home, we know that our pump after 7 minutes will spill. So whoever has put on the pump knows that, I need to go and switch it off after 7 minutes. So that's why we don't have it in our home. Even if you look at it in the industry, there are things like PLC, they are like Unix script, because we exactly know that, how much time water will take or any fluid will take to fill up a given volume. It's simple physics, correct? So there is no need for this particular product, and that's the reason you don't see it, correct? Some of the students nowadays top up, they don't put electrodes and stuff like that. They use this famous sensor, which I keep on saying is that good old ultrasonic sensor. I mean, will an ultrasonic sensor like this work when you have gallons of water? Probably no, correct? And why not use something called as LIDAR, which are, laser guided devices, rather than an ultrasonic sensor, which was quite old, isn't it? Food for thought. Now, microcontrollers, Arduino is a microcontroller, and the use of microcontroller, there is no problem with Arduino. It was there for STEM education, which means it is for science, technology, engineering, and management. And you can read the history of Arduino, and you can look at their official site. It is mainly targeted for people to move into hobby electronics. So the question to you, are you guys doing hobby in engineering? No, right? So there should be some difference of microcontroller which you should learn when you are in engineering, and I'm pretty sure you do it in your syllabus as well. For example, here is a microcontroller from Infineon and Cypress, and this is what it does, and it's a production grade microcontroller which is used in washing machine. Correct? Would you think that your Arduino will fit into a washing machine? Probably no. There would be limitations of power, there would be limitations of GPIO, and maybe it is not production grade, right? Correct. So microcontroller is refers to smallness and controller. So it basically runs a program in infinite loop, and it does a particular task or small task. So putting everything of robotics under microcontroller is not correct. It's not a correct approach. Microcontroller is just a subset of robotics. And when you are making production grade robots, which I'll be talking throughout, you use industry grade microcontrollers like this. Okay, it should be industry grade. Correct? So let's move on. So let's try to design a humanoid with a microcontroller. So there is the famous Ashimo humanoid on an Android, and Honda has been working it for many generations. And if I've read it correct, they're working on this product for 30 years. All right. So what is the first challenge? All right. Let me imagine I give you a project. We are all doing a project. We'll design a humanoid. So as an engineer, what are the challenges you need to solve? And you will quickly see that how just having a microcontroller based solution will not particularly fit for an Android. All right. First of all, the first challenge that will come is that how do you design the body? Okay, when you design the body, how do you design it? You have to probably 3D print it, correct? You have to plan the joints. You have to plan the material, correct? What material would be? Will it be of cardboard? Will it be of plastic? And how do you decide it? Right? So that's where material engineering comes into being, and it is not only in robotics. Things like rocket, a material that works on Earth might not work in space. Correct? So most of you know that ISRO they invented a material which is used in artificial limb, and that was a planned. It was a thing which was discovered as a byproduct when they are planning for their rockets. All right. So the first challenge is the body and the joints, and there is a component of mechanical engineering which comes into play, right? Because for electrical engineering, planning joints, doing the 3D plane, or doing the body might be a challenge. Correct. So you need some concepts of mechanical engineering because you need to define this joint, this angle, and it's just not the angle; it's the reference frame. This arm is moving with the reference frame of the body. The body is moving in reference frame to the torso. The torso is moving with reference to the feet, and the feet is relative to the ground. So there is a whole chain, and which we call as kinematics. So the first problem you will deal with is inverse kinematics and forward kinematics. So that's the first challenge you need to do. So here, if you just have a microcontroller based solution, you might not have the right step. Now imagine you have solved it. Somebody from mechanical engineering solved that problem for you, and you decided that you will go with 3D print. What is the second problem? The second problem is purely electrical. What is my power source? What is my power source for this robot? Most of the robots I see in colleges, they use a 9-volt battery. If you use a 9-volt battery on this, it doesn't have enough current. It has the right voltage, but the voltage is right, but the current is not right because you have so many things to move about. So when your robot gets complicated, your power source becomes a challenging thing. You initially we start with a wired-based solution, saying that we'll power this robot outside. So that's the challenge two you need to solve. The challenge three is what kind of servos or actuators we'll be using. Okay, what kind of servo, and have you tested all the type of servo, and will it be able to take the load of the robot? And then once you solve all this thing, there is a problem of, the sensors. How will the robot see? How will the robot gauge that there is an obstacle? How will the robot know there is an obstacle? Putting an ultrasonic sensor will not solve here, correct? So when we walk, when we drive a car, if I can't see, I cannot drive a car just by hearing. It's not possible. So ultrasonic sensor will not work. Probably you need a combination of sensor. You need a leader, you need an ultrasonic sensor, you need a camera. Now all these components are coming into play. So you have one sensor, two sensor, three sensor, four sensor, maybe 10 sensors are there. How do you code all these sensor in one program? Because in microcontroller, you can only run one program which runs in an infinite loop, correct? So how do you code, 10 to 12 sensor, that too so complex, when you are controlling so many sensors at the same time? So that is the challenge. Finally, the challenge is that, with all this difficulty, probably you will get the robot to walk. It might just walk, all right? But it has to do some job, right? And then if you want this robot to work in a hospital, serving patients, it should know in a hospital where is the door, where are the patient's bed, correct, and where are the medicines probably. So it needs to plan a trajectory of going from here to there, coming from here to there, and coming back and exiting, right? How do you do that? So if you just use a microcontroller based robot, you cannot achieve all these tasks. And obviously, I'm not even talking about artificial intelligence. All right. So artificial intelligence is the final, cherry on the cake, where it can identify jokes. It can do a Google search for you. It can do a basic recommendation, or it can do namaste to you. Correct. Okay. So I'm not even talking about that. So you quickly saw that, how, designing a robot can become an intimidating task with, 6 to 7 challenges upfront I have thrown to this forum. So how do you do this when so many components are interlinked with each other? I know there is electronics, there is mechanical, there is material engineering, there is computer engineering, there is artificial intelligence. How do you integrate all this, from a software perspective, and how do you take care of latency between the software and the hardware? So these are the challenges engineers needs to solve in terms of robot. Now I'll give you the answer, which is that what are actually the robots in 2020. So this is a robot which recently Google has taken over. It's called the Shaft, and it uses kinematics to do some work. Self-driving car is a very good example of robotics, wherein you use things like a leader, things like neural network, deep learning, then you use your control systems to make sure, and you also use path planning, yeah, to make sure that the car is moving. Okay, so the components of robotics which a BTech engineer should be chasing in 2020 are the following. So, okay, and this is not a complete list, and I've tailored it especially for electrical engineers. Kinematics definitely, and I think physics. I'm not sure about your physics 1 or physics 2 syllabus, but this is quite an entry level physics if you're looking at BSc honors kind of a physics. Okay, machine vision, how do you enable cameras to see? How do you enable cameras to see, or how do you enable computers to see? I think, and what are the electronic components of a machine to see it? So I think it's a very important area for electrical and electronics engineer. Your automotive teleoperation, which means you ask the robot to go left, right, back, all these kind of things. Path planning, creating the map and doing the navigation and coming back. Slam, I'll be talking. I have slides on that. Control system, our good old friend control system, right? That is used in robotics. So this is this is going to be there. Battery and power, as I said, that your very old good old friend Ohm's law is going to be there, your friend, because I told you that people need to understand the difference between voltage and current. A 9-volt battery which comes from 4 into 1.5 may not be same as a single 9-volt battery which is coming in. The current might be different. parts of material engineering you should be knowing, and then obviously we are all talking about artificial intelligence and cloud computing, because when you're looking at scalable robotics which can be used in research and industry, these are the main pillars in which we are currently chasing. It's not a fully fledged list, but some of these things which might be new to you, like SLAM, planning, teleoperations, I'll be talking in this webinar as we talk. So hopefully I have solved, I've given you an insight into the first problem statement, that what actually is a robot today in 2020, and how we should correctly use microcontroller. A word of caution: I'm a big fan of Arduino and Raspberry Pi. I use them daily in my life almost. I love them, but I see it more as a STEM product. I see more of it as a hobby product. At best, I see it as a subset, which means that if you are creating a robot, and I'll be giving some example of college level robotics which you should be chasing. So if I have a robot which I plan to do with my BTech students, at best I'll use an Arduino for controlling my motors, which is here. All right, but it would be a subset of my robot. All right, let's move on. Next quote from Kalam sir is, creativity is seeing the same thing but thinking differently. This is very important, right? Robotics is one example. Everybody is looking at robotics. They're looking at movies. They're looking at Facebook ads. But using your common sense, your common engineering sense to plan and skill in robotics, that is what you have to think differently. And this sounds very trivial and simple, as I said in the first part of my webinar. But you need to develop that intelligence to think about it. Example, I gave you that water tank example. Why nobody use a alarm? We don't have an alarm for our water tank? That question should come to you, and then you are thinking differently. Correct? All right. So let's go into the next thing. And this is our first topic, because the last webinar was motivating, and I thought that is the second webinar apart from the goodie. I'll go with little bit of more of technical and with some kind of demo. So the first thing you need to do when you're going for such kind of robotics, when you are doing microcontrollers in your school, at best as first year of your engineering, the next step is go and learn a platform of robotics. And this is an open source platform. All right, and ROS is the name is ROS, and it stands for Robot Operating System. Technically, it's not an operating system; it's a meta operating system. What it means? Suppose you have a Windows 10 laptop. You have a Windows 10 laptop. Most of us have Windows 10 laptop, and then on that I installed Oracle VM, Oracle VirtualBox, and then on that I use Ubuntu or any other Unix-based system. On top of it, I need to install ROS, which means it's a meta operating system. It sits over a host operating system. Okay. It is multilingual. Multilingual money, you can code it in C++, Python primarily, and if I'm not mistaken, you can also do Lisp. All right. Peer-to-peer. Now, this one is important. Now, this brings into the concept which I was talking, that, suppose, you have 7, 8 sensors in your robot. How do you orchestrate between them? Imagine you have, when you're doing an Arduino project, at best, although, there are GPIOs there, I know that Arduino Mega has 64 GPIOs, but if you attach 64 GPIO, there would be performance issue. Probably your power will die, or your code is gonna there is some KB size. How do you code in such KBs for 62 sensor, 64 odd sensor which is there in the Arduino Mega, right? So imagine you have created a robot. Now, very simple robot. So you are designing a robotic car, toy car. It has 4 wheels, and it has our famous sensor like ultrasonic sensor. Then we have sensor for gyroscope. All right, and then also with the microcontroller you need to control your DC motor. Now, due to something, if I have to add another 2 sensor, this project becomes complex, because because of these limitations, that you have limited KV space in the microcontroller to code. Will run out of power, and then you will get performance issues. So one solution is to make it peer-to-peer, which means that I can write a computer program which is like a master. It's same like we do it with flip-flops, and I think all of you are exposed to master-slave architecture, right? So we can have a master, and then we have multiple nodes. Say node one, node two. When I say node, I mean another executable piece of code, node 5, and all of them are connected to the master. And node 5 could be one sensor, node 4 could be connecting the motor, node 3 could be another sensor, so on and so forth. So if you have such a kind of model, it is doing some kind of scheduling, which means when node 5 is not working, it is not getting used. If node 4 is not getting it working, it's not getting used. And in this way, you can actually scale and add multiple sensors, right? You can add 20 sensors to it. Correct. So this kind of architecture, which is peer to peer, they are talking with each other. They're not only talking with master, they can also talk with each other. It's called a peer to peer architecture. It is distributed, which means you are not having a single program which is running in an infinite loop. You are actually having multiple nodes which are running, and each node is doing a part of electronics or a part of hardware or a software task. It is lightweight, which means it is a wrapper. You can write wrapper over the code, which makes it lightweight. ROS as a platform is free. That's why I'm talking about it. And I'll be also giving you an environment which is free. You can reshare it. You can use it for your R&D. You can write your papers on ROS. Okay. You can go and Google some research papers on ROS. Okay. And you can also do your industrial projects. You can do anything on ROS. Okay. It's open source and free. It is maintained by an organization called as Open Source Robotics Foundation, and these are some of the famous robots which ROS uses, and these are all production grade robots. All right. So this one, this robot, again, robots of 2020, hype versus reality. This particular robot is called as a Baxter robot. Just a minute, I just get rid of this. All right. So this kind of robot is a robotic arm, okay, and it is used in warehouse for picking a component from A to B, yeah, picking and picking, a pick and place kind of a thing. It can do other work as metal-based shouldering, metal shouldering. In fact, आपके जितने भी गाड़ी आप देख रहे हो आज रास्ते पे है, whatever car you are looking at the road today has been made. इसका जो body होता है, in automotive, this department is called as body shop. It has almost zero human. Everything is made by robots. All right. So this is a classical example of robotic arm. This particular robot, which you see in the picture, you can take note. This is called the Panda robot. Okay. So it is a very famous. It comes from the Bavaria region in Germany. So this is a German robot. This is how rovers look like. Okay, rovers. In our mission also to Mars, to Moon, we sent rovers, right? Which moves over the surface. It looks like a car. So this is another rover, and if I'm not mistaken, this is from Clearpath Robotics. This is another robot from NASA, and see, it is doing a work of opening this latch. Okay, so it needs to go and open this latch and do some work. And this is a space robot. All this simulation which you see here and here are all designed in ROS. So what I'm talking about is actually heavy stuff engineering here. I'm actually talking engineering. Yeah, I am not talking STEM. Correct. You can simulate real life robots. Isn't it cool? Because NASA का robot कहाँ मिलेगा? So we can't get that in our, but that doesn't stop us from learning it, right? You can simulate it. So this robot, it might cost 70,000 euros, okay, in Europe. So we can't buy it. We know we can't buy it. So, but we can learn the engineering application by simulating it. I have a section on simulation and a research paper to back it up on simulation. There are two versions of ROS, ROS 1 and ROS 2. You start with ROS 1 because ROS 2 has just started. It is getting built. And ROS 1 has an end of life till 2023. So all this, what you see are on ROS, and all this kind of designing, and testing it without the real robot, you can do it. Also, you can test it on real robot. And here is the good thing: you can also run ROS on Arduino, which means if you are still planning to use Arduino to control the wheels, you can interface with ROS because it is such a wonderful product for getting people into the world of electronics engineering, primarily, if not robotics. All right. So in ROS, as I said, I gave the example which I was drawing, and this is given in PowerPoint. Now imagine you have two kind of electronics component to control. So instead of writing one program in C++ in a microcontroller and run it in an infinite loop, I can have the primary ROS running with each other. And then I have a software which I have written for my DC motors, okay, and DC motors with my encoder, and this particular program is registered with my master. I have another sensor, which is an ultrasonic sensor, and I go and register it with the master. I can also have a third one. Maybe here I have the leader, which is my laser-based thing, and this goes and so this is all modular approach, right? It's like Lego blocks, right? You can just play around with it. Now, when I need it, it will interface. Suppose I need to move with the wheel, since it is already registered with the master, this interface can come and there could be an exchange of message that if the master says, go move the wheel, it will go and move the wheel. And it asks to stop, it will stop. So, no, there is also a decoupling which is happening, which makes it a very good engineering solution. So this master, in the world of ROS, we call it the ROS core, and everything which we use, any component, any sensor, any electronic device, or any other aspect of robotics which you want to use is a node. So it goes with a master slave kind of a thing, and it helps to move from a monolithic structure. And this is like single program in microcontroller. And this is the limitation of microcontroller, and there is no fault with the microcontroller. Microcontroller was not designed to do so many things. It was designed to do one or two things in an infinite loop, correct? So microcontroller is doing its job. It is our expectation from a microcontroller has increased very much. So that's not the correct approach. You have to use a microcontroller in a platform like ROS. All right. All right. Problem statement 2. Why do you simulate robotics? Now, the diagram which I showed, especially the NASA robot and the other robots which are shown in some kind of animation, that thing could be new for many of you. Some of you have seen it, some of you have not seen it. I also gave the example of cost, so that we may not have that money, but that's not all the reason. All right. Now imagine you did very well in your engineering. You did very well. You worked hard, and you joined a company or an university which is world famous, and you joined their R&D labs. Okay, and they have a lot of money, okay, and they can buy any robot, and you are specializing in aerial robotics. Imagine ना, you are specializing in, इसको quadcopter मत बोलिए, ठीक है ना, वो भी थोड़ा प्रॉपर टर्म नहीं है, एरियल रोबोट्स बोलिए, ठीक है. So you are specializing in aerial robots, and you have got a robot which is given by your research lab, and you want to do some kind of R&D and engineering on it, and again it is very expensive. Now you don't even know how to drive such kind of devices. Then what do? You have to go and learn how to fly a drone, right? Learn to fly, and then you also take the risk of taking it into a ground and breaking it, and then your boss in the R&D lab gets very angry with you, right? He's not happy. So that's another reason why we go for simulation. All right. The third reason where we go for simulation is, physics. Our mother, right? Our mother physics, because when you are doing a robot in real life, it has to respect the physics. Like an example, the physics in Earth and the physics in Moon and the physics in Mars is not same, right? Correct. Acceleration of due to gravity is one example which is changing. So you have to simulate the physics also. You have to simulate the world. So if a robot is moving in real world, like in roads, like in lanes, in mountain, right? So you have to simulate the physics also, just not the robot. Correct. Right. So example, if you're flying this drone in Bhopal, okay, your RPM of that robot, the RPM of the rotor, which is the motor which is spinning, will be different when you are driving the same thing in Ladakh. Correct? Why? Because air is thin in Ladakh. Class 8 physics, as you go higher, your hair becomes thin. So it has to swing more to get that same kind of thrust, right? Now you want to simulate this situation, flying an aerial robot in Bhopal versus flying an aerial robot in Ladakh, and how does my thrust compare? And I need to create a report. So will you go start flying in Bhopal and then buy a flight ticket, go to Ladakh? It's so much work. You can just do that simulation of physics in ROS. Correct, isn't it? It will not be a perfect solution, but it will give you some kind of confidence, some kind of background. And that is the reason researchers and people in the industry who work on production grade robots, they simulate robots. Okay. But this is not a perfect solution. Okay. And I'm referring to a case study, a research paper, which is, thank you. And it has been made in Creative Commons. I'll be giving the link to your coordinators. You can read this research paper. I've just taken a table. So this group of researchers did a study with a survey that they went to people who are actually simulating robots as part of their day job. All right, the robotics is what they do as profession. Now they said there are a lot of things which are challenges. At times you cannot replicate the real world behavior. Okay, to the degree it is useful. Replicating Ladakh in so much situation might not be so easy. Correct, the complexity, robotics, especially getting this physics up and running, is a complex and time consuming thing. So at times it is not so easy to set up such a thing. And then there are also simulators, they lack the capability. So it is not, we haven't reached a state where it is 100% solution, right? We haven't raised it for robots, unfortunately. But this is the best solution we have today. All right. Example for car testing, we have a foolproof 100% car testing solution. So if a new model of car comes in, there are protocols in every country. There are rules for car testing, and the car has to pass all that tests before me and you can buy. That's not the case for robots. There is no fixed standard when it comes to simulation of robots, and there are the major challenges. So if this area was new, that there is an area of robotic simulation, and there are plus and minus, and you would like to read more, you can read about this research paper which I talked, and you can take it forward. Then how do you simulate such robots? We have a lot of platforms and tools within ROS. Okay, so this slides I'm talking, things which are inside ROS. All right. The first thing is a gazebo, and it is a physics engine, right? So you need to simulate your robot in physics. Let me give you an example. So here is a robot. ये बहुत फेमस रोबोट है रोबोटिक्स इंजीनियरिंग में, इसको हम बोलते हैं टर्टल बोट. And if I'm not wrong, the latest version is Turtlebot 3. It looks like a turtle, and it's a tall boy design. It's a tall robot, all right? All right, so this is the robot which you can see, which is a turtle board, and then the robotics engineer has designed the physics around it, which are the obstacle. This is a desk, this is a cube, probably this is the dustbin, and then it is challenging the robot that, okay, I have given you the physics, and this is obviously my plane, correct? If we want, we can increase the plane also. Maybe I can put an incline of 18 degree to it. If I want, I can do it, and see how the robot will climb up. If I'm putting the right RPM, okay, does it have the right thrust to climb that incline? I can simulate it rather than finding an 18-degree incline plane in my college campus, right? I can do it. I can apply that physics engine and find it. Okay, it has very high quality graphics, and it can be conveniently programmed. All right, this is the code. I'll not talk about it. I'll share the slides. I'll share the environment. When you get the environment, which I said is a goodie out of this webinar, you can just type in this command, okay, and after you run your ROS code, I'll be telling you how to do all this thing. I'll give link to my YouTube channel and stuff like that. EA website, please take a note, and you can see a lot of other things on this particular website, which is the website of Gazebo. Another example here is a stick robot. This kind of robot is called a stick robot, which is a precursor of a robotic arm. Robotic arm, guys, is very important. Like I said, it is used for making cars. As on today, more than 85% of our robots which are live, are actually robotic arms. All right. So this is the robotic arms, and then here also you can solve challenges like there is a joint here. It is joint one. Here is a joint which is joint two, and here is a gripper, right? It will hold. You can put a gripper here like a hand. Again, the angle is changing, right? The relative position of each component. How much, if there is an object here, how much should this gripper move so that it can come and pick it this here and place it here. So that angle calculation, the distance calculation, everything which we call it as kinematics in engineering term or in the term of physics, you can all simulate this rather than going and actually building the robot yourself. Because building the robot might take 5-6 months. You can actually go and simulate it in a week and get your kinematics equations. Same with a multi-rotor. If you have to find your equation of the robot, which will given the weight in kilogram, how much thrust it requires to fly at how much height, those kind of equations solving you can do with Gazebo, and you can simulate the physics. There is another thing which is MoveIt. It is also another component within ROS. Again, I'm talking about a component within ROS. So I'm still in ROS, and well, this actually does with motion planning. So the previous one was simulating physics. Okay, so it's Gazebo, which I talked just now. It was a simulator for the physics, and this one is for motion planning. So one is having a simulator which talks about the physics part of it. The other part is that how do you plan the movement? How do you plan the movement? How it is going to go from position A to B? Okay, so that is actually the motion planning or the path planning. Okay, now this one is used again. It is open source and it is used within ROS. And you can do your prototype, you can do your benchmarking, you can use the inbuilt algorithms, and you can also visualize it and again run multiple nodes. One of the application of such MoveIt is in robotics manipulation platform. So this probably can be a new term, robotics manipulation platform. In simple term, a robot like this is a robotics manipulation platform. It's a combination of a wheel-based robot and a robotic arm, as you can see. So you can move this robot from position A to position B. It can move from position A to position B, and then once it is at position B, it can do some work. Correct? How it will do the work? Using this, using the hand. And again, these are the joints which you can see. Correct? So you have to program the joints, you have to program every electronics component which is there and design it. So this is another simulator which you can use it, and it is called MoveIt. All right. So as usual, the website is here, moveit.ros.org. So go and see it. Okay, go and see it. Learn. There are a lot of simulations I can't show, but there are a lot of examples which are given for industrial and research-based robots, which you can go and see. All right, enough talking. Demo one. That was the feedback I got from the students. That, sir, can we have some demo? So bear with me because I'll be changing my screen so you can see a delay due to the network. But let me go and show a demo. Now, what I'm trying to show is I'm trying to show you a drone simulation. Okay, now I know in movies they show that you have a drone and it has four wings. This is the problem statement with drones. All right, okay, and then you have a dude here who is an engineer, correct, and he has a remote control, correct. He has a remote control with a switch, some switches, and using that remote control he is controlling this drone, and it is flying like 5 kilometer, maybe 10 kilometer. Do you think it is possible, guys? Radio frequency? We all do radio frequency engineering, right? RF, we do it. We talk about radio, and obviously the RF can travel this much thing. But even in some movies, they also show that it is used in defense, like in war. Possible? No, it's not possible. If two parties are in war in modern day, A and B are in a war, both of them have electronic engineer, right? They put an RF jammer correct? If you have mobile jammer, you also have RF jammer. So moment your drone enters a jammer, it will just fall down. It's sitting duck. What about the delay in real time? Because you're looking at the drone going and doing, probably it has a camera also, and you're looking at the camera, but there is some latency, right? Correct. So how do you account for that latency if you're taking it so ahead? Correct. How does it navigate? Do you think the pilot has to be very capable to just navigate with the remote control? How does it navigate? How does it create the map? Sometimes you can also put a GPS on top of it, right? So that it has a GPS. But the same problem with GPS, your GPS can be manipulated, when it comes to such kind of a things. Or worse, if you are in a mountain, you can lose your GPS, correct? So how do you do such kind of things in a robot? Finally, the challenge of battery. If you have flown a toy-based multi-rotor, you know that battery is a challenge. You cannot fly for 2 3 hours with current battery technology. At least the whatever battery technology we have for ready to buy from the retail market, you cannot have such small size battery which will fly for 2 3 hours. It will at most give you 7 to 8 minutes of flight time. So you cannot do so much stunt in 7 to 8 minutes of battery, correct? So these are the actual challenges we have with drone, and I'll be showing you a simulation of drone as a video. So just bear with me. So I'm just closing the share. You might see a flickering of your screen, and then I'll come back again.
The participant can put your questions on. We'll be taking the question answer in the end of the session.
So can you see my screen?
Yes, it is visible.
So as you can see that this is the drone which is flying. It's the drone is called Hector drone, and it is flying with a simulated physics of a tunnel, and it is trying to make its movement, making the predictions of in which path it has to go. For example, it is not going and colliding with that particular tunnel, and then when your drone is able to take that particular flight in such a kind of physics, you are happy that your drone is fit for purpose. So as you can see, it is moving into a treacherous terrain, and it is taking inputs both from itself using uh, algorithms such as SLAM. It is also creating maps using the camera, and also using path navigation algorithm, and also there is an override options from the remote control from the drone pilot. So these are the kind of simulation, and this is the aerial view on your left, which you can see. This is the aerial view, which is coming from the camera of the drone. This is how the drone is actually looking at the camera. And the path planning is actually happening with reference to the ground. So this is the ground and this is the drone. And this kind of simulations you need to do when you're actually going into robotics engineering. And this is what I am talking. What this is what I was talking about, the challenges that how would you do when you have to actually build a drone which will work in real life and do some kind of job. So this kind of simulation, as you can see on top, it's written Gazebo. It's a Gazebo simulation. Okay, so this was one example of simulation which you can do. It looks amazing. First time when you see, it looks confusing, but then once it becomes a habit, like any other particular product or software, it becomes easy. All right, so I'll just move into my slide. All right, all of you can see my slides. So we'll go for a break for 5 minutes now. All right, and as Professor Neeti said, you can post your questions in Q&A, and I'll come and pick up those questions. So, Professor Niti, can you go for a break for 5 minutes?
Yes, sure, sure.
So we'll catch up after 5 minutes. Give me 5 minutes. Yeah, thank you.
Okay, okay. The participants, there is a break of 5 minutes. So I request all the participants to please put your questions in the YouTube. Can take up in the last. And I request Amit sir, if you can please put a slide here, or can we put the
Okay, ma'am. Okay, ma'am.
creative here, or should we continue like this only?
Professor Niti, I'm back.
Yes, sir. Please carry on.
Okay. Can you see my slide? Can one of you confirm, please?
Yes, yes,
All
it is
right.
visible.
So here is another quote. Thank you so much, Professor Nidhi. So welcome back. I just stressed myself, and all of you also probably had a good break of 5 minutes. So here is the next quote from Kalam sir, and he says that all of us do not have equal talent, but all of us have an equal opportunity to develop our talents. Correct? Right? Example: all of you might not be the same page whenever it comes to any subject or any area of interest, but all of you have 4 years in BTech. Right? So use these 4 years to become a better engineer. All right, such a wonderful statement. All right, so now let's go to a use case. अभी projects करे तो क्या करे? So that's the next question, right? And so I have taken the opportunity to take the Google Map for your institute in Bhopal, and in my last webinar, I have talked about my Bhopal connection as well. Now, this is probably the image of your campus. My apologies if I've taken the wrong screenshot or something like that, but I tried my best. Now, एक robot बनाते हैं, which can be done as a final year project. All right, let's try to brainstorm. Okay, we can start from third year, and by fourth year we can make this robot. And obviously, I'll use a microcontroller and your motor driver like L293D. Correct? That's the IC, if I'm not mistaken, which are commonly used. I'll also use a Bluetooth kind of a thing, which are easily available. And I'll take a remote control car and I'll make a body of the robot, but I'll also add a GPS to it, and let's try to solve a problem. What is the challenge? The challenge of this robot is that the robot, which is here, imagine this is the robot at the main case of Sagar Institute of Research and Technology. It should take a full campus run, outskirts of the campus. And it's when a robot is going, when a robot like this is going for a campus walk, campus run, anything can happen. Example, the robot is here, and then the first year they come and surround the robot, and the robot has to stop because the first year they're super excited to see the robot, and they have stopped its trajectory. So the robot should stop and wait for somebody from third year to come and say, okay, side though, and then again it moves. When it comes here, it should understand that there is a boundary wall of Sagar Institute of Technology, and then it should take a left and not take a right. Because on right there could be a gadda, there could be a trench. Correct? So how do you do it? Obviously, the quickest way of which is pure pure electronic solution is the GPS, right? You use a GPS, global positioning system. You code it and you used a microcontroller, probably Arduino is the better. आप use Arduino Pilot, okay, which has the GPS capability with the Arduino base, and it is also used for rovers and drones, and it does a path planning based on your GPS thing, right? So this is a pure play electronics implementation which you can do. So step one, you do it with pure play electronics. Do a GPS based robot, okay? Forget ROS, MOS, all this thing. Go and do this step. Once this step is done, you implement it with a platform like ROS, where it can create a map. Its own map, not the map which is given by the GPS. It will use both. It will use input from the GPS. GPS might not be totally correct, Or what happens if your robot loses GPS? Imagine जब ये रोबोट इधर पे आ गया, इधर पे आपकी ट्रीज है, your campus is green, I assume, and there is a lot of trees in this area. So your robot will lose GPS. Correct. आपका triangulation काम नहीं करेगा. So that time it can use ROS based map to navigate and decide कि भाई अब हमें left जाना है. So this is one robotics project which you can definitely do, and I think step one is definitely achievable when you create a a platform like this and use a microcontroller based platform with GPS like Artifial. So go and give it a shot and at least move to step one on this kind of robot. And imagine if you're doing it, it would be really cool because it is very interesting to look at a robotic car which is taking the campus around on a predetermined path given by GPS. You are not controlling it, although you can have a remote controller, and that's the reason a Bluetooth is given just to override, the robot. But I think that's a good start. But my lecture now is going to be how do you go to step two? Because step one, I'm pretty confident that you'll be able to give it a start and give it a go. So if you're interested, third year, fourth year, go give it a shot as your project. Speak with your faculty members. My email ID is there. If you need some additional inputs, I'm happy to help. Okay. Now, this is the area where probabilistic robotics comes into play, and this is the section two of the robotics. This link is very important, and take a note of this link. Here you will find a lot of PowerPoints, a lot of research papers, a lot of small video snippets of robotics which are using probabilistic robotics. Now, this is the definition. I'm not going to read it. You can read it later or now. And as the name says that probabilistic robotics uses probability of uses the fundamental concepts in probability and uses it in the field of robotics to work in real world scenario. Let me give you an example. Here is our friend robot. This is my robot R, and it has obtained an initial measurement which is Z. Now this Z could be that this centimeter that the door is open. It could be any value which the robot has found out using its sensor. Maybe there is a camera here, which is a camera. Maybe this is the leader. This is a camera, and maybe our famous ultrasonic sensor here. Yeah. And it has calculated the value of z. Now, what is the probability given z that the robot will be able to use this arm and open this door? So that is the problem statement. Now, E formula all of us know, and this we know as Bayes theorem, right? This is that theorem, in which, examples always work. But in question paper, it is never mentioned apply Bayes theorem. So most of us apply permutation and solve the paper and come and then realize, अरे ये तो Bayes theorem का problem था. Those kind of thing. All right. So good old Bayes theorem, and you see how wonderfully engineers have put it into application because what is the probability that I can open the door given Z and I can use Bayes theorem to break it up. Given the probability of Z, I'll open and given the probability of Z, and this is a worked out example which all of you Bayes theorem is fundamental to all engineers, and you can the robot can find out what is the probability that it will open. So example, you can then further code the logic of the robot that my probability if it is coming less than 0.5, I'll not send the robot. Do not send the robot. Why? Because 0.5 is a half chance. It's half chance. So for a perfectly unbiased coin, it is a coin toss. So you are taking luck. Correct. You are taking chance. So you use probability saying that, yeah, this is less than 0.5, I'll not take. Whereas if you're getting a probability of 0.813, you'll probably go and take that chance because it is no more a chance, and probably you have a high chance that the robot will go and open the door. So this is one simple application of probabilistic robotics using our good old theorem of Bayes. All right. So as you can see that Bayes theorem, we always see the example of card playing, picking card from a box, but the application of Bayes theorem today has also included in the field of robotics. So that's it's a very simple way to tell you how statistical robots, these are also called as statistical robotics, is getting used. This is a very emerging field, my friends, and this is the emerging field both in the industry and also in research, R&D. So if you're looking for some papers to write and an area to do your next journal submission and stuff like that, I would strongly recommend that you look into this area, because the probability part which is coming for a research scholar or for any faculty member, it's trivial. For student, I think they have to brush up their mathematics, but I think any professor in any branch of engineering, the probability that this robotics use is very fundamental. So there is a the application has to be researched, and also then there is a state transition, like it does not stop here. Once the robot opens the door, there is a chain, chain of probability. You can take probability of A multiplied with probability of B, that will give you all these things we know. It can use such kind of laws or other advanced laws, saying that once the door is open, it does some work. What is the probability that it can close the door? खुला छोड़ के नहीं आना चाहिए. It shouldn't leave the door open and not close it. Okay, that's also a problem. So it can also look into the chain of probability when I do a straight transition. What is the transition? Open the door and close the door. Correct? So here the formula changes, right? And then it says that if there is a 90% probability of success. So you can read about these things, and this is a very wide and a big area, and my job is to just give you the inertia, show you the door, and then if you like it, you can take it up. The next concept, coming back to that again, our robot which we talked about, the robot which will take a campus victory run and come here and everybody is happy. And how do I do it in ROS? Because we know that we can use a GPS-based pure electronic solution. So that is stage one. Stage two category. Stage two category, we use a concept called a SLAM. All right, SLAM is a very fundamental problem statement in robotics engineering. Okay, again, it is used in the industry and it is also used in research. You can go and I know students who are currently doing their PhD or have done their PhD in the world in the area of SLAM. It stands for simultaneous localization and mapping. Now, what is localization? Localization means look at this robot position which is here. What is the reference frame of this robot in retrospect of this area, right? So what is the position of the robot in retrospect of the campus of SIRT, correct? And mapping is a map. It creates a map, as you can see here. That if I have to go and take a victory lap, probably it creates a map like this for SIRT, and it creates itself looking using whatever sensors are available, right? So here is one example of a blog, and this one I have taken from my own work actually. So I would encourage all of you to go and uh, read this blog. It took some time for me to go and set it up, all right? But go and read this blog, which is there in my personal blog site, which is anirbanghatak.com. And here I'm trying to create a robot which one has a teleop. Teleop matlab remote control. Yeah, in the world of robotics, we call it teleoperations. And here as you can see, these keyboards, U for forward, K for right, something like that. You put it. You can also increase the angular velocity by 10%, 20%, which means here the first year, they came and they're excited. So I'll not increase the speed. But moment I cross the first year, this road is empty. So I'll make it fast, go fast, increase the speed, right? So I can press some keyboard and that kind of daily operations I'm talking. And then it creates a map looking at all the possibilities using probability, using probabilistic robotics, and then it creates a map like this as a deliverable. And more you make it run through the campus, the more better it becomes. So this is one example of SLAM, and it is also used in probabilitics robotics. So SLAM is a fundamental problem statement which we try to solve. And again, if you are able to solve SLAM, you can definitely showcase that robot. You can, if you have a SLAM robot, go ahead and show it to the companies visiting your campus that we have solved SLAM. Yeah. Especially company who are from mechanical manufacturing domain, artificial intelligence domain, they will appreciate your work. All right. And you have a two-step implementation wherein you have electronics doing the GPS based, and you also have robotics engineering doing the SLAM. All right. So it's a win-win. All right. So you move from a single branch of engineering into a collaboration of engineering stream, isn't it? So this is one example which you want to do, and do read about SLAM. There are a lot of research materials available on the internet. If you have access to international journals, do go and search today, right itself on SLAM. All right. Other problem statements which you can do, and again, this is not a fully fledged solution. You can use problem statements in robotics like PID. This stands for proportional, integral, and derivative. I think this is there as part of control system, if I'm not mistaken. Okay. And if you like control system, you can use it. Application, you can use again a quadcopter or preferred aerial robotics. You can also do a hexapod. Okay, hexapod are like those robotic spiders, right? It has 6 legs, 8 legs, and how do you do the feed of it? It runs on infinite loop. There is a feedback mechanism that works just like a control system. Kalman filter is another thing. It is used not only in robotics, it is also used in machine vision. So if you are interested to work in the world of in the area of electronics engineering, which has to do with the cameras and the camera-based sensor, Kalman filter is another area. It is also used in robotics. Monte Carlo simulation. This is known for the faculty members. Taylor series. This is known again for the faculty members. Students also know it. This is there in M1 or M2, and this is used widely in many fields of research, mathematics, physics, and robotics also. You can do and do a project about how Taylor series is used in robotic. Sensor models, motion models, mapping occupancy, discrete filter, wind locomotion. The SIRT example of the map which I talked about is an example of wind locomotion. Particle filters, all these things you can do research, and these are all part of probabilistic robotics as well. So these are 1 to 10 areas are the areas on which you can either file your research paper. You can read about them as a hobby, as an interest, as an engineer, or you can also create projects over it. All of them are an application of probabilistic robotics, and these are some problem statement which I gave. Obviously, in addition to that, you can also do SLAM. The SLAM I didn't write in this slide because I've talked about it in my presentation. I'm almost at the end of it, because this is my second last slide, because we have the Q&A coming up, and then it's holiday. I think all of you can go home. So the key skills required. All right. Before that, here is me. Okay, and the key slide is skill one is temperament. Why? I could have used terms like coding. Yeah, I could have used terms like maths. I didn't use it. I used temperament. Okay. So here, look at me. Here is me. Okay. And here I am trying this shooting him. Okay. And firing my arrows. And this picture was there at the start as well when my introduction was there. And if you look at the arrow position, it's horrible. See, it's outside, 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 outside. This is the bullseye. एक भी arrow नहीं लगा मेरा. Zero. But I am happy. Why I am happy? Because this is the first time I fired arrow in my life from a professional bow and arrow. A carbon fiber. These are made of carbon fibers. And I say that, first time I shot an arrow using a professional bow and arrow. And I was happy that, my scores were bad, but I'm happy that at least I have used professional bow and arrow and not the ones which are made by bamboos, which I used to do when I was a kid. So I think that temperament matters, that when you are learning something new, you should be happy and not focus so much on the initial results, right? So that temperament has to come up if you are, trying to move into the world of robotics, data science, anything new. So the temperament has to be right. If your temperament is not right, it's a problem. Burning desire towards robotic research. And when I say research, I mean both research as in PhD, research as in writing papers, and research uh, in the sense individual research, which you use in common sense के यार R&D करना है, individual research, self introspection, that I'm really passionate to learn about it. If you don't have that burning desire, you will go out of energy. Okay, because this is an emerging field. This is an emerging field. So you have to do a lot of. You should have that burning desire in all this three segment. All right. Now, what are the hard skills in regard? These are all the soft skills I talked about, but very important skill. And for me personally, those are very important. All right, and that's why I talk at them as number one and number two. Hard skill पे जाते हैं, you should have good grip, okay, on signal processing, control system, and embedded system, because depending on the type of robots you use, you can be using an 8-bit, you could be using higher order bit of embedded system. Control system, as I said, by now you want understood that there are a lot of things which actually needs control system. PDU is one example of control system. Signal processing, no brainer, because you need lot of digital signal processing for the robots to communicate. Engineering, physics, and mathematics, non-negotiable. Although if you are tying up with your mechanical department, I'm not aware if you have mechanical department in the campus, but if you have, it is a good idea to always keep the friends from mechanical engineering involved, because especially with the body, the design, and the physics, all these things comes very naturally to a mechanical engineer, which for a CSE and triple E, it could be an outstretch. There are exceptions, but if you don't have it, then your focus would be kinematics, motion, geometry, and calculus. Okay, it's both integral calculus and derivatives, partial derivatives, everything which you do in engineering. You should be really be able to understand and how it works in the real world, not just solve the question. Solving question is just one way. You have to understand how it is used. Like I showed you, how Bayes theorem uh, is used. All right. So that those kind of application. Unix. Now a lot of people have said, "Sir, I'm electrical, I'm electronics. Why Unix? I don't know Unix. I don't want to learn Unix." And as usual, my answer is that, "Arey, you know, Unix is co-created by your department. One of the co-creator of Unix was an electrical engineer. Correct. You guys created it Unix. It's your gift to the world, and now you're saying you can't do Unix. ये बात हजम नहीं होता, right? So go and learn Unix. It is not negotiable. It's not that tough. Go and spend some time and learn Unix. Without Unix, robotics, especially the robots which I talked in the webinar today, it's going to be challenging, if not impossible. So all these things they work on Unix. C++ and Python. When I say Python, I actually mean coding in Python. And this, anyways, you are doing for your placement, for your data science, for anything. So Python has become more or less the de facto standard in engineering today in India. Now, here is a catch. In C++, I actually, when I say C++, I mean two things. I mean C++ package building. How do you create and develop a package in C++, and basics of data structure? Again, I think this is a paper for most engineering branches, data structures. All right, and the packages which you used, if this is new to it, you can make packages in Catkin, CMake, Catkin, Colcon. And the reason I'm saying this is that ROS works on those packages. So when you code it, after coding, you have to create a package, because then once you make the package, you can execute it, as a node within your ROS thing. ROS, because this is the meta operating system. You need a meta operating system because I gave the humanoid example, and I gave the car example. There are so many moving parts. There are, you have to take care of physics. You have to take care of so many sensors, actuators, cameras, GPS. So you need a meta operating system which goes and interfaces with them as distributed kind of communication. So ROS is one platform. There are also commercial equivalent of such products, but they are not available for students. They are all industry grade, and most of them I have found they're very expensive. All right. Microprocessor also is another key area, especially things like single board computer, microprocessor, because when you are using for complex calculation, and you have to take care of time and all those things. Okay, and some algorithms you just cannot run without knowledge of microprocessor. So these are the core skills which you need to know in terms of making the next move. I think you have to stretch yourself because what I understand from the students, I interact with Unix and I think C++. Most electrical and electronics students, they say that this is too much for us. But I give you the example that you guys co-created Unix, and you just cannot say that we can't do it because you guys created it. Simple, right? So thank you guys. That's the last quote, and this is the last quote which Kalam sir said in the United Nations, and he quoted another Tamil scholar 3,000 years ago. And the scholar has written 3,000 years ago, my dear friends, 3,000 years ago. This is 2020, even starting of calendar before that. And the poet writes, I am a world citizen. Every citizen is my own kith and kin. And he's saying that, today we are global. We should work as kith and kin, like family member, and be a global world citizen. So think global, be global, try to make a global impact, and then you will be happy, then you will be successful. I'll be opening up with Q&A. Just 2 more minutes to go. You can give the feedback, and I would request Neeti ma'am to put this link in the chat as I speak. So please go and put your feedback, because I'll be taking the feedback links for my next webinar if I'm coming. And also I need to send you the goodie that I promised, because I'll be taking the email IDs from the feedback form. So if you want that goodie, go and fill up that feedback form. You can visit my blog, especially the one I showed on Slam. You can go and read how I did it. There are some codes given. There are some mathematics also done, which I skipped on this, the extension of the base theorem. The website is anirbanghatak.com/blog. Please do subscribe to that. My YouTube channel, if you're a YouTube guy, this is how my YouTube channel looks. And, I do a lot of videos on ROS, and you can go and see ROS. There are also free tutorials which are given on ROS, which will go and get you started on ROS. So thank you so much, Niti ma'am. I'm all done. I'm ready for question and answer.
Thank you, Anirban sir, for the wonderful session. What I thought, you'll be giving the idea superficially, but you have taken it so deeply that I was also motivated. Faculty member and researchers and students might have the all the thrust you have given to do the work and to do the projects in the field. I'm glad to share that this year Smart host 6 students from our institution got the prize of rupees 1 lakh, and their work is also in the same area. So glad that our students are doing good in this area, and our session will increase their, the upcoming also there. So the lecture will put a very good thrust for them to work in this area in future. So we'll be taking a question and answer round. Asking, do the AI can possibly remove human potent in future? Artificial intelligence is there any
So the
remove the human
question is
potent in
that will.
future?
Oh, okay. So the question is that can AI remove humans in the future? No, AI versus human. Now, where is AI standing? Although this is not core in the thing, although they are related, AI is also used in other fields rather than robotics. Example, AI is getting used in the field of marketing today, okay, which has nothing to do with robotics. Just a word of caution there, okay? It's also a wide field, just like robotics. So the answer is no. I think there are different opinion. My personal view is no, because where we are in terms of AI is that we are still figuring out cognitive abilities. My screen is visible, right?
Yes, yes, yes,
Okay.
it is.
So what I mean by cognitive visibility abilities is see here, okay, smell. Now think about an electronic circuit which can see. Answer is camera. Here, hearing aid, and smell, maybe gas sensor. Okay, but what these things are doing, they're actually taking the physics and mapping it into a mathematical data or model. Correct. But when you say about cognitive skill, it means that when you see a food in camera, okay, okay, you see bhel puri, and you say, यार लॉकडाउन हो गया 6 महीना मैंने भेल पूरी नहीं खाया रगड़ा पैटिस or you see a cake. Okay, I can't go outside and eat cake, so I'll bake a cake. That decision you take. So we haven't reached there, in terms of looking. We can still identify where we have reached. We can identify face, we can identify cat, dog, identify if a person is smiling. Okay, that's it, where we have reached. So that is far away. Hearing and smelling, those kind of thing in artificial intelligence, we have not reached. Example, your mobile cannot smell if there is a gas leak in your home unless you install something and stuff like that. So the road ahead in terms of cognitive ability is very far. Okay, so that is only in cognitive we are so behind in terms of AI. Now, when you talk of the other things, when you talk about engineering psychology, cognitive ability is not everything. Imagine there is a train driver. He or she is driving a big train, and suddenly a cow comes on the track. So the first thing that the train driver does, the loco pilot does, is that pulls the brake, right? That person brake. So here, that person does not think, he's not using, so much of planning. There is non-cognitive thinking also that, I need to just go and do it. You're driving car. When you are driving a car, you don't think, if you're driving for 3, 4 years, you don't think that, okay, now I'm running on second gear, I need to go to third. It just happens. So those kind of other thing, which is, which we call as, common sense or practice, those things are far, far away. So in terms of the timeline, both in terms of neuralistic programming, cognitive skill, it is way behind the time schedule. And then uh, there there is also a factor, ultimately, that's position I don't think it will reach, where computer programs will go and become so intelligent and they start ruling. So I know that there are a lot of people who goes against this thing and they like to have thrill and think that this is going to come and go away. But I think that is way, way far. And that is also not the use case. Because when you do research, I think professors would know there is a very strong ethics in research. You cannot go and research in something which will teach a machine to fall in love. It is unethical by laws of research, isn't it? So this is not going to happen because our research community will stop it. They will not get funding, which ultimately goes and creates problems for the humans we stay in. All right. So don't worry about it. Use artificial intelligence as a collaborative tool. And as I said, the near fruit, the money is actually flowing in terms of the industry projects and job is actually in other fields of AI, applications of AI, more in the area of banking, more in the area of marketing. The ads you see when you see a YouTube video, all this kind of thing is actually getting implemented in the world of AI as we speak. speak today. So I wouldn't be so much concerned or afraid. I would rather take it, I would embrace it. One thing to note that, always remember that, if there is a difference between a technology upgrade, and there is a difference in a machine replacing. For example, we after Second World War Two, we had a lot of people who are working as telephone telephone operator. Okay, why? Because your signal processing was analog, and then digital signal processing came, and this job went out of the market. So this is because of a technology progress. It does not mean maybe that person were not bad, they were actually very good as telephone operator, and then if you do not embrace technology at the right time, you become obsolete. All right, so there is a difference, because of technology advancement and total replacement. So I think we should be clear about what we are talking. So don't be afraid. Go and embrace AI as an engineer. Learn it, apply it, and if possible, contribute to the community of artificial intelligence. Next question, please. Hello.
Yes, yes. Hello.
Yes, I can hear you.
Yeah, thank you for the nice explanation. And I can relate to that telephone exchange example because my father was also working in the same area in railways. And in 2004, he got transferred from that department because due to the technological advancement, the telephone exchanges were not needed that time because so much of the mobile came. So that railway has actually shut that department, and people has been sent to the other department. So I can relate to that example very well.
Yeah.
And thank you for answering this. And another question is there from Sumit Patel. He's asking that simulation is virtual. So how can we possibly know that what are the defects or faulty motors or the angle of swing the real quadcopter is acting? Is there any way we can detect the faults in quadcopter? That is what he's asking about.
Yeah, I mean, there are two aspects of it. Aspect one is that, as your quadcopter is flying, you are supposed to take readings of it as you do in your lab. And then if the quadcopter crash, you can investigate why that quadcopter is crashing, because you cannot change the physics, because physics you have modeled, right? So if there is a mountain, the mountain will not move. You have to manipulate it. So if your quadcopter is crashing, you can see at what spot, at what area and what kind of physics it is not able to follow. It may be possible that if there is a mountain like this, it is able to see the distance and calculate and fly. But if it is coming suddenly, suddenly something is coming. Again, there was a mountain, but here suddenly another object is coming, and it is not able to see that certain object coming in, and it crashes. Maybe a bird coming in the path, right? Your quadcopter can fly between a given distance of 5 feet. Okay, that it is able to do, but suddenly a bird coming in the trajectory, it is not able to stop or move back. So maybe you can use and try to see that what can you do in such a case, and take corrective measures. But reading is the main thing which you actually do when you are simulating. Yeah.
Thank you so much. There is another question from Uttam Jha. He's asking, what is the scope of nanotechnology in robotic science?
The scope is huge actually, because when you are talking about nanotechnology, although this is not my area, so I'll not be talking much. In nanotechnology, what is happening is that we are talking about micro robots today. And these are micro robots again, are robots which are injected inside the human body, all right? And they move through your blood vessels, take reading, and take the reading outside and put to a device. The robots which you can actually swallow, and or they are implemented. So those kind of things are also getting implemented. Another much simpler and low hanging fruit are wearable technologies. Yeah, wearable technology. Example, like you can design a jacket, I'll give you a project idea. You can use nanotechnology and wearable technology. You can marry these two concepts and design a jacket. And that jacket could be, imagine somebody driving a scooter, and that person is wearing that jacket. And if that person has to take a ride, not only the LED of the scooter will do right, but the jacket, which has the light in it, also will emit the light. Isn't it cool? And you can connect the jacket with the scooter using Bluetooth, correct? So those are the applications of nanotechnology. But as I said, nanotechnology is not my field. It's a totally different area. But these are the two things I can think offhand. But yes, it's a very good area to be in. Yeah. Next question, please.
Thank you for giving the nice answer. And next question is from Mr. Priyansh Tiwari. He's asking, what are all the microcontrollers we can use except Arduino?
What are microcontrollers can you use except Arduino? I think microcontroller, obviously, uh, colleges generally before Arduino, they were also using microcontrollers before Arduino. They were using a microcontroller like PIC. I think the faculty members will know. I think PIC was the name. You can use Arduino. I also told about Artifial. All right. So these are all the initial microcontrollers you can use. After that, you have to move towards industrial micro microcontrollers. If you remember, I gave you the example of washing machine. All right. What I do is that when I send out the slides, I'll add more microcontroller names for you. So which are more powerful than Arduino, and you can use them with your projects. But if you're happy with Arduino, go and use Arduino, especially if you want to use GPS. Next question, please. I'll add those other names other than Arduino, which you can use.
Sure, thank you. This is all from my side. Vivek sir, is there any question from your side? Vivek sir, is there any question from your side? Or should we conclude? I think we have done with all the questions. So thank you so much, Anirban sir. Can you put that slide in which you have described your yes this one. Thank you. So I thank you again for giving all such knowledge you have discussed, right from the ROS to the robotic manipulation platform, the demonstration of drone simulation on ROS using joystick, and statistical robotics, SLAM. And I must say you have clubbed the robotics and the curriculum very well, so that the student have, the hitch has been gone. I think that you have told them to study control system, signal system, and embedded system, so that they can. And the Unix example I really like. You told that I was not even aware of the fact that Unix was co-created by one of the electrical engineers. So I think students now will get enough motivation. And you have also told us about the Taylor series Kalman filter, PID controller, discrete filters, and particle filters applications in robotics. So I think when we'll be teaching students about these, and they'll be if they're interested in robotics, they'll study it well. So I thank you again. Thank you so much, Anirban sir, for the wonderful session, wonderful lecture, and we are getting excellent feedbacks on the chat box also. I'll share the YouTube chat link with you also, so that you can also read these feedbacks. And we have a separate feedback link also, which is available on the screen, as well as we have shared in the WhatsApp and Telegram group, which we have particularly joined for this particular event. So I request all of the participants to please fill the Google forms, so that you will be getting the certificate. After feedback, you will be having the link for certification. So please give your honest feedback. And I thank you again, sir, for taking the wonderful section. And I would like to share one certificate, which is a form of gratitude. Amit sir, please share the certificate. Yeah, so this is the certificate, Anirban sir. Thank you so much from our department, from our organization. Thank you so much for sparing your precious time with our students and all the participants from all over all this. There are from 11, 12 states from India. We have having the participants. So it is a very wonderful experience with you again. So thank you so much. Thank you so much once again.
Thank you, everybody. Thank you, Professor Niti. Thank you, Sestok. Thank you, dear students and participants who dialed in through YouTube. Thank you so much, and hopefully we'll meet again. Thank you.
Okay, okay. Thank you. So that is all from our side. Thank you all the participants for joining. If you have any question, Anirban sir is humble enough to give your answers. So on his, you can read his blog or you can mail him regarding your queries if you have any, or you can message me also if you have another question. If somebody has, you couldn't have asked, so you can contact me for that also. So thank you so much. That's all
Thank
from.
you.
Thank
Bye
you.
bye. Thank you. Bye
Bye.
bye.